Yeah, in this session we are continuing with the numpy. So in the last session we learned how to create a numpy array, how to create one-dimensional, two-dimensional arrays. We learned about the axes, dimensions, shapes of the arrays. Now let's say we have to create numpy array, which should be that it should get initialized with some value. Let's say maybe 0. Then we can use np.zeros, where np stands for numpy, and we can specify the size. So it creates a array of size 4 and all the elements are initialized with 0. Similarly, we can specify a two-dimensional shape. Let's say np.zeros as 3, 4. So it creates a numpy array with the shape of 3, 4 and all the values are initialized with 0. There is another one, np.ones. It creates array and the values are initialized by 1. At the time of initialization, we can also specify the data type. For example, if you see in the previous one, the data type is float, it's 0 dot, yeah. Now we can specify the data type as int also, so it creates array with the values as integer type. So we can say np.ones3, so it creates a one-dimensional array which has 3 elements and all of these are integer type. Similarly, we can give the shape as of a two-dimensional array, 2, 3, np.ones, 2, 3, and data type as int, so it creates an array which is of the shape 2, 3, that is 2 rows and 3 columns, and all are integer type. So that way we can create arrays which are initialized by values zeros or ones. Yeah. The next is to sort the elements of the array. So we can use np.sort function. So what we do is just specify np.sort and the name of the array. It sorts ascending order the elements of the array. Let's say we have a two-dimensional array, array 2D, and these are the elements. If we want to sort it, then what we have to do, we have to specify the axis based on which we have to sort the elements. If we are giving axis as 0, then it means it will sort on the basis of the rows in this direction, along the rows, yeah. So let's say np.sort array 2D and axis is 0, sorting along the axis 0, that is along the rows. It will sort like 10. First it will come 6, then 7, then 10, 6, 7, 10. If then this one gets sorted as 9, 19, and 21, it will remain same, yeah. And if this last third elements get sorted as 3, 5, and 8. So that's how you sort it on the basis of x is equals to 0. We can also specify x is equals to 1, then it means it will sort along the columns. So along this way, along the columns, this way, and this way. So elements get sorted as 5, 7, 9, then 8, 10, 19, and then 3, 6, 21. So if you see 5, 7, 9, 8, 10, 19, and 3, 6, 21. So that's how we can sort the elements of array by specifying the axis where we want to. Next is the structured array. In the structured array, we specify the names of the um, elements and the data type. So let's say we have a data which is basically a list of tuples. So each tuple consists of three elements: name of a person, age, and the gender. And then we have the data type, which is a dictionary. It basically consists of key as names, and then it specifies the name of the columns. First element of the tuple represents the name, second element represents, let's say, age, and third element represents gender. And the format, that is the data type of these individual elements. U10 means Unicode string of size 10. This is integer type, so int, and this is Unicode string of size 1. Yeah. Then we just simply say np.array data. Data is the actual data which contains these tuples as a list, and then the d type, which is the data type. So it creates a structured array, just like this. Now we can sort this array by specifying the name of a specific element. Let's say if we want to sort it on the basis of age, then we say np.sort, then the name of the array, err underscore data, and then we specify the order as age. So it will sort the elements according to the age. So it will give on the ascending order of the age 28, 33, 40. Now we can similarly also sort on the basis of the name. what we just have to do, we have to call np.sort function, name of the array which we want to sort, and in the order we specify the specific column based on which we want to sort. Here we give name, so this will sort the array based on the names in the alphabetical order. Okay. Another is we can also specify the conditional access. Let's say we want to access the elements of this particular array such that we want to retrieve only those elements of uh, array where the age is less than 30. So we see that only this particular is the element which has age less than 30. So what we do is arr underscore data is the array, and then we access its age column, and we just give the condition less than 30, which acts as a boolean conditional logic, true or false. So whichever elements return true for this particular condition, those elements are returned. And from the output we just want to retrieve only the name column. So if we run this, we get the output as current. So it means current is the only person whose age is less than 30. Now we will cover some aggregate functions. These are the commonly used aggregate functions in day-to-day working with numpy. So let's say we have an array with a couple of elements and we want to find out the sum. We just simply say np.sum and the name of the array. It will just sum it up and give the result. To compute the average or the mean, we just say np.mean, and the array it will compute the mean and it will return the result. Similarly, to compute the standard deviation, we give np.std. std stands for standard deviation, and the name of the array it will return the standard deviation. Variance is np.var. Using np.var, we calculate the variance of the elements. Minimum and maximum we calculate using np.min, and the maximum by np.max. Median is by np.median, and within bracket name of the array we get the median value of that array. Percentile, to compute this we use np.percentile. We specify the name of the array and then the which percentile we want to compute, like 25th percentile, 50th, 75th, and so on. And we specify, like, let's say 25th percentile of that particular array, the value returned is 4.75. Another is we can use numpy.log to calculate the natural logarithmic value. So we just say np.log and then the value, it will calculate the natural logarithmic value of this, the value which we pass it. We can also calculate np.log 10, so where the base is actually 10, so we can use np.log 10 and then the value, let's say 100, then the value returned is 2. Now let's say if we want to calculate log of a base which is not given. Let's say we have log 10, similarly we have log 2. Let's say we want to calculate the log of base 40. Then using this formula, log x to the base b equals to log of c to the base x divided by log of b to the base c. So basically using this formula we can just calculate. So what we are doing is np dot log of n is the actual number whose log we have to calculate, divided by np dot log of base, where base is the base which we want to use to calculate the value. So this is the value we get. Now we can calculate minimum and maximum and other functions also on a two-dimensional array. So the difference with one-dimensional and two-dimensional is that we have to specify the axis at the time of calculating the aggregate functions. Let's say we have this two-dimensional array and we want to find out the minimum value, and we can specify the axis as 0. 0 means along the rows that we already know, and so along the rows means this side. So along this side, if you go along the rows, you see the minimum is 6, then in this 9, and in this 3. So 693 is the minimum. Now np dot max, and x is equals to 0, so we have to find the maximum along the rows. So maximum along the rows is 10, 21, and 8. 10, 21, and 8. Similarly, minimum and maximum we can find along the axis 1. 1 is, that is along the columns this side. So np dot min of this particular array, where axis is 1, is along this side. If we go find out the minimum is 5, and then 8, and then 3. So 583. Similarly for maximum is 9, and then we have 19 and we have 21. So 9, 19, 21. So so that's how we calculate minimum maximum along a given axis. Now another thing which is very important in NumPy is the broadcasting. So there are three rules in the broadcasting. Rule 1 says, let's say we want to perform operations on two arrays and they are not of the similar dimensions, that is the shape is different. Then what we have to do, we have to find out array which is of lesser dimension, and then we pad 1 towards the left of the dimension. Okay, and rule 2 says that if there are two arrays which do not equal in the dimensions, then we extend array where the dimension is 1 to match it to match it with corresponding the second array. And rule 3 says if the final arrays which get created are not of equal size, that is they disagree in the size, then we just get an error. Let's take an example to understand it. Let's say we have an array A with elements 3, 4, 5, and array B with 1, 2, 3, and 5, 6, 7. So basically A is a one-dimensional array. It has three elements. So the shape of A is 3, and B is a two-dimensional array, 1, 2, 3, 4, 5, 6, 7. So it has two rows and three columns. So two rows and three columns, that's the shape. Now let's say we want to perform addition between A and B. Now we'll go through the rules 1, 2, and 3. Rule 1 says that let's say compare the shape of A and B. So A's shape is 3, B's shape is 2, 3. So A is smaller in dimension. Okay, then what the rule 1 says is we have to left pad 1 in the dimension. So basically we have to add 1 towards the left of 3. So towards the left of 3 means this side. So the dimension of A becomes 1, 3 as per the rule 1. Now rule 2 says if this array and array B, they are not of the same dimension, then the array which is having 1 in its dimension, it should be extended to match the array B. So it is extended as per the rule 2. So 1 is extended to 2 because B is having 2 in its first axis. So now A also becomes 2, 3, and B also becomes 2, 3. B is already 2, 3, so we can just simply add it up. So if we add A and B, what we get is elements of A get added to elements of B. So 3, 4, 5 gets added to 1, 2, 3. We get 4, 6, and 8. So 3, 4, 5 gets added to 5, 6, 7. We get 5 plus 3, 8, 4 plus 6, 10, and 7 plus 5, 12. So addition is possible. Let's take another example where we have array A. It is of shape 3, 2. These are the elements of A, and array B is a one-dimensional array with just two elements in it, 10, 20, and we want to perform an addition. So again, let's compare the dimensions of these two. We have array A and array. So as we see, the shape of A is 3, 2, and the shape of B is 2, which is one dimensional. Now, as per the rule 1, we have to find out, compare these two and find the array with the lesser in dimension. So B is lesser in dimension. Okay, so we have to put 1 towards the left of 2. So the shape of B becomes 1, 2 as per rule 1. Now we compare this with the shape of A. Okay, so we find that this is the one in this dimension, so we have to extend it to match it with the corresponding value in the another array. So we have to extend it to make it 3, 2. So this 3, 2 of B and A 3, 2 matches, so it means operations can be performed between A and B, and we just simply add it. We get 10 gets added, 10 and 20 gets added to each of these, so we get 11 and 22, 11 and 22. So 10 gets added to 3 is 13, 20 gets added to 4 is 24, so 13 and 24. This is the second one. So 10 gets added to 4 is 14, and 20 gets added to 5 is 25. Now let's take another example where we end up in a situation where the operation is not possible between the two arrays. Let's say we have array A, which is of shape 3, that it is having 3 elements in it, and array B, which is of two-dimensional array, and this shape is 2, 2. Now, as per the rule 1, we have to compare the shape of A and B. Okay, A is of lesser in dimension. Okay, so we'll pad 1 towards the left of 3, so its shape becomes, as per rule 1, 1 comma 3. Now we have to extend the axis, that is this one, to match it with the corresponding axis of the another array. That is, we have to extend 1 to match it with 2, that is, this will become 2. So the shape of A final shape will become 2 comma 2. This is the new shape, and if we try to perform addition with B, it will give into error. Okay, there was a slight correction I did. So actually, uh, after matching it, I should write it 2 comma 3. Okay, so after rule 2, the shape of A becomes 2 comma 3, which is not matching with B's shape of 2 comma 2. So if we try to add A and B, then we get an error as expected, because it doesn't satisfy all the rules. So that's it for NumPy session for now. Thank you.